Hi everyone. In this video we're going to show how to graph a cube root function. A couple things that we'll need to know. One, we'll need to know the inflection point. The inflection point is the point at the center of the graph around which the cube root graph has the rotational symmetry. We'll want to know whether or not the function has a reflection over the x-axis, and then just to get an idea of how steep or how shallow the curve is, we can find one other point, and then we'd be able to see the rest of it just from the rotational symmetry. So we're going to graph f of x equals 4 cube root of x plus 1. We start by finding the coordinates of the inflection point. Again, we can do that by setting the expression under the radical equal to 0. I'm not doing an inequality this time like the square root graph because I don't need to know the domain. I already know the domain is negative infinity to positive infinity. So I just want to know, where did I move cube root of 0 equals 0, which was the inflection point of the parent function. So by setting underneath the radical, which is just x equal to 0, I know that that part's 0, and then I can find that f of 0 is 1. Other way to think about this, just thinking about transformations, I know that there's no horizontal translation or stretch or reflection or any of that stuff. The only translation I see is 1 unit up. And again, since it's starting at the origin, the vertical stretch won't affect this yet. So I do the same thing. I set the expression under the radical, which here is just x equal to 1. Again, that should make sense that it's just going to stay 1 because there's no horizontal transformations at all. And so f of 1 is just 5. And now I have enough information to make my graph. Because there's no reflections at all, I know that it should be pointing the same direction as the parent function, like that. So, lastly, I'm actually ready to draw the curve. So I have my inflection point that's at 0, 1. I have my second point here that's at 1, 5. And for my third point, knowing the rotational symmetry, I can just go the other directions. So if I go down 4 units on the y-axis, and I go 1 unit to the left on the x-axis, I can get my third point, and so now I can just draw my curve. And now I have a really good, accurate, sketch with some important information to give me a good idea of what this function's graph looks like. Again, notice we pretty much followed almost the exact same process we did as for the square root function. It's just a different shape, and of course the domain is negative infinity to positive infinity because negative numbers are allowed in the domain. And again, other things to think about. Use your common sense about what the graph looks like. When you're looking at the radical, you don't have to follow this set of steps to get the x values. You can really just kind of think about them in your head, like what x values would give me nice numbers if I took the cube root of them, looking for 0s, 1s, 8s, 27s, etc. And then just knowing that you can just plug in the x value to get a y value. Again, the main point, this is one way to draw the graph, but as long as you have something that's accurate, correct, and it makes sense, there's lots of different things that you could do to give yourself an accurate idea of what the graph looks like.